Hello everyone, we are going to be solving daily Leetcode problem given on 28 July, that was on Monday. So this is with respect to 2044. Before starting this problem, let us have a small motivational quote. Actions speak louder than words means what you do matters more than what you say. Promises and talk are cheap. Real character and credibility come from consistent effort, integrity, and results. People will judge you by your behavior, not your intentions. What respect, trust, or change? Want respect, trust, or change? Show it through actions, not just speeches. The world rewards doers, not dreamers, right? So we should appreciate the people who are already able to achieve certain things, and we should also become one of the doers in this world, right? So that's one thing that I wanted to specifically bring out from this quote. Let's try understanding this problem. This is a medium type problem. Given an integer array nums, find the maximum possible bitwise OR of a subset of nums and the number of different non-empty subsets with the maximum bitwise OR. An array A is a subset of an array B if A can be obtained from B by deleting some possibly zero elements of B. Two subsets are considered different if the indices of elements are chosen different. The bitwise OR of an array is equal to A of 0 or A of 1 or if uh, all the indices, right? I hope this is having to define what an subset of an array means and also the OR operation. Okay, so let's look at these examples. So in the first example, there is 1 and 3. The subsets that are possible from 1 and 3 are these, and the maximum value from these two OR operations will be 3, which would be 1 1. And when you do an OR operation on this one, it will also give you 1 and 1, which is equals to 3. And 3 OR operation of 1, which is equals to 1 1 or of 0 1. This is again equals to 1 1, which is equals to uh, decimal value of 3. So both subsets are returning a maximum value, right? And in case of this one, all of the values are 2. So all non-empty subsets of 2 have a bitwise or of 2. There are 2 power 3 minus 1, 7 total subsets, right? So 7 is the value. Uh, Similarly, in the example 3, we get to see these are the possible subsets where OR operation would lead us to a maximum possible value of 7. And these examples should give us a few information on how the subsets are calculated and also the maximum value out of these subsets, how are they derived, right? So for example, 3 is defined this way, and OR operation of 5, that is 2 power 1. So 101, out of these, this will give us a value of 7. Similarly, all of these will give us a value of 7. That's these are the possible subsets, and this is the output. 6 are the subsets that give us this value of 7, right? Okay, so that being said, let us understand what is the approach that we can take to solve this problem. So, so one thing that we can do is first, given the nums array, we can iterate through all subsets and compute or of their values and keep track of a maximum or value seen and the count of subsets that result in max or value, right? This is our approach. So for us to do this 3 steps or possibly 4 steps, uh, we would be doing it this way. Firstly, we would need to calculate the maximum XOR value. Uh, we can do that to calculate maximum OR value. Iterate all nums of uh, input and calculate the max OR value. And next, through backtracking, recursion, we can we can explore all possible subsets. Uh, we can use all the possible subsets and we can calculate the number of subsets or value. Okay, so this is our approach, right? So we need to understand how we are going to establish this recursion process. So I will write a brief approach on how we are going to do the recursion. So for this uh, backtracking function, we are going to do it this way, where let's say we say a function which takes in an index and also current XOR. Initially, this will be 0. Let's say if index is equals to nums dot length, this is the breaking condition, then we can return current XOR if is equals to max, or then we can return 1 or 0. That's the first case. That is, if there is no values, then we can simply return 1 or 0. And let's say if so, let's say for this function, for this backtrack function, we would be starting with two options. That is, one, either include firstly we would start with 0 and 0, and then we are going to progress it to backtrack itself with the index plus 1 and also the current XOR and nums of index, and also uh, two things. I will write this backtrack function again here. So let's say we create a backtrack function. This is going to take in index and current XOR, The breaking condition being if index is equals to length, then return 0 or 1, 1 or 0. So this current XOR will be an initial, so this backtrack function will be initialized with 0 comma 0. This is the starting case. And once if there is no nums dot length and no length of the array, then we can simply return 1 because the current XOR value will be 0 and this will be the max XOR value will be 1 only. And if uh, we need to further backtrack it, then we would say return function backtrack, that is index plus 1, to move to the next element, such that uh, we consider the next set of values. And also we use current XOR, current OR, and if we need to keep track of the, let's say we are given with 1 comma 2 as an input, so we just send in the new value. We also need to process it somehow, right? So if current XOR is equals to max XOR, then we add in return the crucial condition, this crucial if loop in the uh, current OR is equals to max OR, then we say return nums of nums length minus index. This would give us all the possible subsets. So this is the crucial piece of logic, and we can come to this logic by setting in functions, a function such as index plus 1 to backtrack to the next possible subset, and also sending current XOR, current OR, sorry, I keep saying XOR but it's OR, please excuse me, uh, function index plus 1 and current OR along with the nums index to consider the specific value. So if I will need to do a dry run on this problem, so let's say uh, we would be given with an input 3 comma 1, let's say this is our nums array. Then let's say we start with backtrack of 0, function call with 0 comma 0, and we know that nums length is 2. This would be the first case where we check if it's length, then we operate the if loop, else we continue where we check current XOR is equals to max XOR, max OR, then we return, then we would be returning uh, 1 left shift by nums length minus index, right? So this is like uh, we are taking this piece of element, right? So this would be like length minus index. So this left shift operator is equals to dot pow of 2 power. This is like an exponentiation of 2 power to the value. So it would be like 2 power 2, and this would give the number of subsets. Uh, and the return of this backtrack function, where we would ask the return function to either include it or exclude it, would be index plus 1. And in the second parameter, we either take the current or with the nums of index, that is the individual part of the number, or the each individual part. This is one way to include the specific number, or to just not include the number and just do the OR operation to find the maximum no, subset that contains this maximum OR value, right? So this is our recursive function. So I will quickly move to the Leetcode editor, and let's see if you can understand something from there. So now in the Leetcode editor, we will be solving this problem. So first thing is we need to find the maximum XOR value out of the nums array. So this will give us the max or operation of the nums array, and with this we start our backtrack function. This would initially take in 0 and 0, which would be equal to current OR. And now to the main part, where we calculate all the subsets that have this max OR value. Uh, this will be the count of index. We can either use math.pow, or we can say left shift and bitwise left shift of. So these are the possible subsets that we can get out of this specific number that we are doing, right? So the way to have subsets formed with the backtrack function would be the way that we further backtrack this. So one is we obviously need to go to the next index. and also current or plus v current or plus the nums at index. Okay, so either we include the specific digit to consider the specific digit in the or case condition, or we just consider the entire piece of nums, right? So that's what we are doing either here. I will quickly correct this typo. So I can initiate this backtrack function and quickly close this up, right? So let's try submitting the solution. I would like to hear more comments on how this backtrack function is working uh, in the comments if you have clearly understood it, or if you feel like this was something tricky to understand, right? So one logical error that I made a mistake here was instead of adding or, so this should solve the problem. Time and space complexity of the solution, while this gets submitted, I'm hopeful this gets submitted, yeah. So the time and space complexity of the solution is n square, as we are iterating through each subset uh, two times, and also the space complexity would be uh, 1 or n, because we are having to store the max or n times, right? So time and space complexity of the solution would be n square and n. Hope you found this video helpful. Please let me know about the backtracking functions that we have defined here, and also let me know if you have understood what this is doing with respect to finding the number of subsets, right? Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.